Astronomers have just announced a discovery that is rewriting the cosmic record books. The most powerful black hole flare ever observed. This unprecedented event saw a supermassive black hole unleash a blast of light equal to 10 trillion suns, momentarily outshining its host galaxy and stunning the scientific community here on Earth. Let us explore this further. In the vast, silent theater of the cosmos, something just screamed. A single cataclysmic event so bright, so powerful, it momentarily outshined its entire galaxy. This is a story of a cosmic explosion unlike any ever recorded. A burst of light from a distant black hole that at its peak shine with energy of 10 trillion suns. This isn't a science fiction. This is a new mind bending reality of our universe. The discovery announced recently by astronomers challenges everything we thought we knew about the power limits of the universe. The source is supermassive black hole at 10 billion light years away, known as J2245 plus 3743. We are looking back in time to an era when the universe was still relatively young. First spotted by Zwicky Transient Facility in 2018, this black hole began to brighten dramatically, increasing its luminosity by a factor of 40 over just a few months. For years, scientists watched in disbelief as the number climbed. What exactly happened at the heart of that distant galaxy to create such an unprecedented spectacle? To understand the flare, we must first understand the beast. Almost every large galaxy, including our own Milky Way, houses a supermassive black hole at its core. These aren't just empty voids, they are surrounded by a vortex of superheated gas and dust called accretion disk. Black hole flares, as a natural part of their life, they are usually caused by turbulence in that accretion disk magnetic field lines twisting and snapping, creating energetic burst. But what happened at J2245 plus 3743 was in different class entirely. It was a tidal disruption event or TDE. Imagine a large star, perhaps 30 times the mass of our sun, straying too close to the black hole immense gravitational field. The side of the star closer to the black hole feels a far stronger pull than the other side. This difference in gravity, known as the tidal force, that stretches the star into a long, thin stream of gas. Scientific calls this gruesome process spaghettification. As this shredded stellar material spirals into the black hole, it collides, heats up to billions of degrees, and generates an unbelievable amount of light and energy. The sheer scale of the star that was devoured, combined with the power of the black hole, estimated to be about 500 million times the mass of our sun, created a perfect engine for the brightest flare in history. Let's try to grasp the number. Our sun is a powerhouse. It converts millions of tons of matter into energy every second. Now multiply that power by 10 trillion. The light emitted during the peak was so strong that the black hole temporarily outshined every star in its entire host galaxy. According to the study, the total energy released since the flare began is equivalent to taking the entire mass of our sun, converting it all into electromagnetic radiation, following the Einstein famous equation E is equal to mc square. The researchers led by Matthew Graham initially didn't even believe the numbers. They had to rule out other less extreme possibilities like a massive supernova. This event is not just powerful, it's a cosmic time machine because the light traveled for 10 billion years to reach the Palomar Observatory in California. We are witnessing the black hole as it was when the universe was only about 3/4 of its current age. This is a rare window into the mechanics of the giant black holes in the early cosmos. And here is one of the most fascinating detail. We are watching this event in slow motion. The expansion of the universe stretches not only the light wavelength, a redshift, but also time itself. Astronomers estimate that 7 years of observing the flare here on Earth translate to only about 2 years of the actual time near the black hole. We are essentially watching the cosmos, or sort of a cosmic drama play out at a quarter of the speed. The flare, which reached at its peak, brightness in 2018, has been slowly decaying ever since. But even years later, it remains significantly brighter than its original, state. This tells scientists one thing: the black hole is still feeding. The enormous star has yet to be fully devoured. The location is also significant. Most TDEs are found in quiet galaxies where the black hole isn't already actively feeding. J22453743, however, is an active galactic nucleus, or AGN, a black hole already surrounded by a bright accretion disk. This makes TDE much harder to spot as they are, camouflaged by the black hole's regular glow. The sheer brightness of this flare allowed it to stand out even against its own fierce background. This discovery provides a critical test for astrophysical models. It forces us to revise our understanding of how large stars are formed within these active environments and how much energy can truly be liberated when the matter meets the ultimate gravitational predator. It opens a new line of inquiry. Are there more of these ultra bright flares lurking in the archival data, simply miscategorized? The 10 trillion sun flare is not an ending, it is just a beginning. It confirms that universe is capable of spectacle far beyond our current textbook and shows us that black hole, the great destroyers, are also the most profound illuminators. They are the engine of the cosmic transformation, and we are only just learning how to read the light they send towards us. In the ongoing quest, the map the cosmos. Events like 10 trillion sun flare are our guiding star, a brilliant reminder that the edge of the discovery is not a place but a question. And the universe is always ready to give us an astonishing answer. So, friends, what are your biggest takeaway from this cosmic event? Let me know in the comments below. And if you found this journey fascinating, please like this video, subscribe to our channel, and ring that bell for more deep dives into the wonder of the space. See you in the next one.